Yes, students will continue the rest of the portions of trigonometric functions. Now we have completed exercise 3.1, part of 3.1, and we'll consider the other questions of 3.1. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? That is a question. A wheel makes 360 revolutions in 1 minute. In 1 minute, it is making 360 revolutions. Through how many radians does it turn in 1 second? So, what is 1 minute is equal to 60 seconds. And number of revolutions in 1 minute is equal to 360. 360 in 1 minute. So, number of revolutions in 1 second is equal to 360 by 60. 360 by 60. Number of revolutions in 1 second you are finding out. That is equal to 360 by 60 is equal to 6. When the wheel makes one revolution, what happens when the wheel makes one revolution? It turns through 360 degrees or 2 pi radians. When the wheel makes one revolution, it turns through 360 degrees or 2 pi radians. So what is the question? Through how many radians does it turn in 1 second? Number of radians it turns in 1 second is equal to 6 into 2 pi, that is equal to 12 pi radians. Okay, now next question. In a circle of diameter 40 centimeters, the length of the chord is 20 centimeters. Find the length of minor arc of the chord. In a circle of diameter 40 centimeters. So diameter of the circle is equal to 40 centimeters. So you know that the radius is equal to 20 centimeters. The length of the chord is equal to 20 centimeters. What do you mean by a chord of the circle? Chord of the circle means it is a line segment whose endpoints lie on the circle. So there can be different types of chords. The diameter is a chord. Chords of smaller length, chords of bigger length, we can find out. But here we are considering a chord whose length is 20 centimeters. That is, this length of the chord is equal to the radius of the chord. That's a speciality. Length of the chord and the radius of the chord, they are equal. Now, when you construct that, let us consider those points as P, the center O, and Q. PQ is equal to chord, that is 20 centimeters. OQ is equal to the radius of the chord, that is equal to 20 centimeters. Now, you know that OP is also the radius, it is equal to 20 centimeters. So, now you can say that triangle POQ, it is an equilateral triangle, it is equal to 60 degrees because all the three sides are equal. So, that is what I have written here. Angle POQ is equal to 60 degrees. 60 degrees, I have to convert it into radians. That is equal to 60 degrees is equal to 60 into pi by 180, which is equal to pi by 3. Now, the question is, what is the length of minor arc of the chord? What is the length of minor arc of the chord of length? Let L be the length of minor arc of the chord. Then what is the relationship between the central angle, the length of the length of minor arc, and the radius? You know that theta is equal to L by R. That is theta. What is theta is equal to? Pi by 3 is equal to L by R, or that is L right here. Pi by 3 is equal to L by radius is equal to 20. So, L is equal to 20 pi by 3. If you want, you can take it as pi is equal to 22 by 7 or pi is equal to 3.14 approximately. So, you get the answer is equal to 20.95 centimeters. So, these two questions are clear to you? Okay, very simple questions. Now next one, I'll write the question. If in two circles, arcs of the same length, same circle subtend angles 60 degrees and 75 degrees at the center. Find the ratio of the radii. If in two circles, arcs of the same length, arcs of the same circle subtends angles 60 degrees and 75 degrees. So, one angle, subtended angle is equal to 60 degrees, that is equal to 60 into pi by 180, which is equal to pi by 3. Other angle is equal to 75 degrees is equal to 75 into pi by 180. 5 ones are 5, 5 5s are 25, 5 36. 3 5 are 15, 3 12s are 36. So that is equal to 5 pi by 12. And the relationship between theta L and R is equal to, theta is equal to L by R1. Now the question is, find the ratio of their radii. So let the radius be R1 and R2. We have to find the ratio of R1 and R2. That is, in the first case, pi by 3 is equal to arcs of the same circle subtend angle L by R1. Mark that as equation number 1. And the second one, 5 pi by 12 is equal to L by R2. Length is the same, arcs of the same circle. So arcs are the same, the angle is different. Now let us divide second equation divided by the first equation. It is equal to 5 pi by 12 divided by pi by 3 is equal to L by R2 divided by L by R1, or 5 pi by 12 into 3 by pi is equal to L by R2 into R1 by L. 5 cancel, 3 4 times. 5 by 4 is equal to L and L cancel, R1 by R2. So what is the ratio of the radii? Ratio of radii. R1 is to R2 is equal to 5 is to 4. R1 is to R2 is equal to 5 is to 4. Now we will move on to the next concept. I think I have done the 3 important questions in that exercise. The remaining questions you can work it out. Because this is the second time I am taking this chapter. Now, let us consider a unit circle. What is the meaning of a unit circle? Radius is equal to 1 unit. Let us consider a point P, A comma B. This point is 1 0 because it's a unit circle. This is 0 comma 1, minus 1 comma 0, 0 comma minus 1. Now from P you draw a perpendicular. Let it be equal to PM. PM is equal to A, MP is equal to B, and OP is equal to 1 because OP becomes the radius and it is equal to 1. Now let this angle be equal to theta. So from the figure, what is sin theta is equal to? Sin theta is equal to B by opposite side by hypotenuse, that is B by 1. That is equal to B. What is cos theta is equal to? Adjacent side by hypotenuse is equal to A. So this point A comma B can be taken as the x coordinate becomes cos theta, y coordinates becomes sin theta. So in this case, when the angle is equal to 0 degrees, when theta is equal to 0 degrees, we can say cos 0 is equal to 1 and sin 0 is equal to 0 because x coordinate is cos theta, y coordinate is sin theta. Now, when it moves an angle of 90 degrees, theta is equal to 90 degrees, or that is equal to pi by 2. Cos pi by 2 is equal to 0. Sin pi by 2 is equal to 1. Sin pi by 2 is equal to 1, x coordinate and y coordinate. Now, when theta is equal to 180 degrees or pi, cos theta is equal to cos 180, cos pi is equal to minus 1 and sin pi is equal to 0. When it comes to this one, that is theta is equal to 270 degrees or 3 pi by 2, it is cos 3 pi by 2, it is equal to 0. Sin 3 pi by 2 is equal to minus 1. And when it completes one rotation, 360 degrees, 2 pi, cos 2 pi is equal to 1, sin 2 pi is equal to 0. So, from the unit circle, you get the standard values 90, 180, 270 and 360. You can see that the value of sin theta and cos theta varies between, the range of the values varies between plus 1 and minus 1, whereas the domain can take any real number. So when you plot the graph, you can say that sine graph y is equal to sin x. When you plot the graph of sin x, minus 1 plus 1 0 0 pi by 2 pi 3 pi by 2 2 pi minus pi by 2 minus pi minus 3 pi by 2 and minus 2 pi. Sin 0, the graph. Sin 0 is equal to 0. Sin 0 is equal to 0. Sin pi by 2 is equal to 1. Sin pi is equal to 180. Sin 3 pi by 2 is equal to minus 1. Sin 2 pi is equal to 0. When you join them using a smooth curve, this will be the graph. And this rotation is in the anti-clockwise direction. When it is in the clockwise direction, it takes the form 0, this is a graph of the sine function. So what is the domain of the sine function? Domain of the sine function is a set of all real numbers. And what about the range? Range is equal to closed interval minus 1, 1. It varies between plus 1 and minus 1. And the domain, it can take any value, any real number. This is how you get the graph of the sine function graph. You have to remember the domain and the range of the sine function. Amplitude, it varies between plus 1 and minus 1. Plus 1 and minus 1. And domain, it can take all real numbers. It is on the x-axis. Similarly, you have to find the graph of the cosine function. What is cos 0? Cos 0 is equal to 1. Cos 90, 0. Cos pi, minus 1. Cos 3 pi by 2, 0. Cos 2 pi, 1. Smooth curve. This is a graph of the cosine function, and here also the domain of the cosine function is the set of all real numbers, and the range of the cosine function is minus 1, minus 1. Domain and range. You should see that cos 0 is equal to 1, whereas sin 0 is equal to 0. Cos 0 is equal to 1. 0, 1. Sin 0 is equal to 0. So it starts from here and it goes like this. So this is the difference between the sine function graph and the cos function graph. After 2 pi, again the same rotation goes on and on. Next one we have to study is signs of trigonometric functions. What are the signs of the trigonometric functions? Now, when we consider the quadrant, first quadrant, second quadrant, third quadrant, and so on. In the first quadrant, x and the y-axis are positive. X and y are positive. That means when you consider the point P cos theta, sin theta, both sin theta and cos theta are positive. That is, it's from 0 to 90 degrees. In the first quadrant, it is 0 to 90 degrees. Because sin and cos are positive, in the first quadrant, sin theta, cos theta, positive. So what happens? Sin theta and cos theta positive. Cosec theta will be positive. Sec theta will be positive. Tan theta will be positive. Cot theta will be positive. So all the 6 trigonometric ratios will be positive in the first quadrant. And in the first quadrant, it is from 0 to pi by 2. When it comes to the second quadrant, what happens in the second quadrant? In the second quadrant, sin is x is negative, y is positive. So x is negative means cos theta is negative. Sin theta is positive. Cos theta negative means tan theta will be negative. Cot theta will be negative. Sin theta positive means cosec theta will be positive. But cos theta negative means sec theta will be negative. So in the second quadrant, you can see that only sin theta and cosec theta, they are positive. So here the angle is pi by 2 plus x. Pi by 2 plus x, or you can say that it comes up to 180 degrees. So it is equal to pi minus x. In the third quadrant, when it comes up to the third quadrant, what happens in the third quadrant? In the third quadrant, x is negative, y is negative. So x is negative means cos theta negative, sin theta negative. Both are negative. So tan theta becomes positive, because tan theta is sin theta by cos theta, negative by negative, positive. So also cot theta becomes positive. But sec theta becomes negative and cosec theta becomes negative. So in the third quadrant, you can say that tan is positive and cot is also positive. And here we can say that it is pi plus x, more than 180. But it goes up to 270 degrees or 3 pi by 2. So it will be 3 pi by 2 minus x. 3 pi by 2 minus x. And in the fourth quadrant, x is positive, y is negative. X is positive means cos theta is positive, sin theta is negative. Cos theta positive means sec theta is positive. Sin theta is negative means tan theta is negative, cosec theta is negative, cot theta is negative. So, in the fourth quadrant, you can say that cos theta and sec theta both are positive. The rest 4 trigonometric ratios are negative. And here we can say that this is equal to total angle, it comes up to 360 degrees, or this will be 2 pi minus x. 2 pi minus x in the fourth quadrant. 2 pi minus x. So these are the signs of the trigonometric functions. So suppose if a question comes like this. What is the sign of sine 135 degrees? What is the sign of sine? Whether it is positive or negative, or what is the sign of sine 135 degrees? Sine 135 degrees comes in the third quadrant. So it is negative. What is the sign of tan 135 degrees? Tan comes as positive in the third quadrant. 135 degrees means, sorry, I made a mistake. Sorry. Sine 135 comes in the second quadrant. So this is positive. So suppose if I ask you, what is the sign of tan 135? Tan 135 comes in the second quadrant and the sign is equal to negative. Sign is equal to negative. So these type of questions can come for one word type questions. So you have to know that x coordinate corresponds to cos theta, y coordinate corresponds to sin theta. And in the first quadrant, all trigonometric ratios are positive. In the second quadrant, sin and cosec are positive. In the third quadrant, tan and cot are positive. In the fourth quadrant, cos and sec are positive. So there is an abbreviation. Students used to memorize it as all students take coffee. That is in the first quadrant, all trigonometric ratios are positive. In the second quadrant, students, S, sine and its reciprocal, cosec. Sine and cosec are positive. Take, T. In the third quadrant, tangent and its reciprocal, cot, are positive. And in the fourth quadrant, coffee, C, coffee. So cos and sec are positive. So this you have to memorize it. All students take coffee. All, first quadrant, all are positive. Second quadrant, sine and cosecant are positive. Third, tan and cot are positive. Fourth quadrant, cosec and sec are positive. So we will continue with the next class. Thank you.